Innovations, director of the world's fastest supercomputers, explained how they did it. The world's fastest supercomputer, called Frontier, is whizzing away in the National Laboratory located in the foothills of East Tennessee. It's the only machine in the world that has ever demonstrated that it could perform more than one quintillionth. Wow, quintillionth. Wow, how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 number is quintillionths calculations per second. Do you know how many zero? It's 18 zero quintillionths per second in the language of computer science is called XROP. Frontiers project leader Justin Wheat told IE has his favorite way to explain the scholars his team achievement is to imagine if every single person on earth could put out a pen or paper and do one simple math problem per second, if all 7.8 billion of Earth, 7.8 billion of Earth work day and night, it would take 4 years to do the amount of maths that the Frontier can do in a single second. Wheat started his career as a fluid dynamist. My primary interest in supercomputer was using them to solve hard fluid dynamic problem, to design things like an aircraft, wind turbine. He arrived at the Oak Ridge National Laboratory 2009, worked on the Kraken, which was the point of the world's third fastest supercomputer in 2018. He was taped the lead of Frontier projects. The interesting engineering reason sat down with Wheat to learn more about the Frontier and get the story behind the fastest computer on the planet. So this interview is being edited. IE, is a supercomputer just a really big computer, or where are the distinctive attributes? Is to make supercomputers qualitatively different. Wheat in somewhere, yes, supercomputers are very similar to the normal computer, like your desktop or laptop. Has a lot of same components, similar one. Or a supercomputer has many central process unit, many graphic process units, which is Frontier has segments is the system into the notice. There's about 9,400 nodes in the Frontier system. Each of these NODES nodes is a central process unit, CPU, and the 4 graphic process unit. Those are our GPU, so already they note NODE is a lot more powerful than the typically laptop and the desk. So get more update. But then the difference really start to the compound, because each of these nodes, each components has to be able to talk to every other's components, the system, because it's basically you are writing software, and that goes out leverages all the hardware at once to do its calculations. So keep things each of these components has talked to every other components in the system. They are all connected with high-speed network. That's something your typical computer doesn't have. So when you think of computer, normally you think, well, it's got a hard drive, or computer doesn't have the hard drive or data written out of separate high-speed storage system. Is also connected over high speed, however. So with this, regardless of the application, if you talking about modeling and simulations, it's different physical phenomena. You are talking about different technique for machine learning, AI. Most of these programs involve multiple metrics, particularly one of the models is the simulation side. So basically you are modeling and simulating system equations. So in a computer you are represent lots of these very large matrices. When you solve the matrix, you end up you have two multiple matrices analysis. It's a lot of work of the system. So these operations per second going to the multiple matrices we live and breathe in and algebra. So with the Department of Energy, with a Department of Energy's computing project start with establishing that is there need of new computers. So you look at what scientists are and engineering are doing on the current system is very formal process, where it's DOE, write a mission statement. So say in a time frame, we need this much more computing power. Let's happen back in the 2018. From there, you start to define what it look like, how you meet. What are all the different ways you can meet their needs? So you need to be done accomplished. However, the VDE, you break down into a lot of really big steps. Then you break loads of down into the small step. So basically, you are freaking out what expert you need to, what the resource you can draw on. So in instance, you might not think that deploying supercomputer take a tremendous amount of constructions, but with Frontier, you did, because the meeting not the missions required, bring the additional power cooling infrastructure to the data, and the computer would be sitting. So brought additional 30 megawatts. 30 megawatts electrical power, so 40 megawatts cooling capacity to the building, just to able to the house the Frontier system. About the same time, the constructions activities began to working with different scientific team to make sure their applications, their scientific code and the scientific software was ready to go on the system when it get there. So we put a lot of efforts to working with the scientific team, providing them the technology along the way they can pour their application to them, ready to reassign on the machine on day one operation. At this point, it covered 3 years. We a little over 3 years into this project. So we have been refurbished the data center, hardening our internal infrastructures, getting it ready, connect the computer when it get here. So then we have been working with the vendor and to design the prototype and the technologies for the system to test those along the way. So we say these projects are executive normally is public and private partnership in the case. After comparative bid, the process building the system select Huipu, Wheeler Pack, HP, enterprise and their subcontractors, advanced micro device AMD, to work with the Packard Enterprise to Huipu, responsible for the building the computers itself. AMD is responsible for producing the different processes to go into the computer. So they each have their engineering staff. They often working with the prototypes, have a subject material expert. So on our side, so they are working on the co-designed process with them. Through the process called the non-recurring engineering, they are getting prototype, testing them. They are evaluating them and providing the feedback design. So, which is being all the inspiring, is being the incredible part of it. It's closely stems through the moonshot I have ever been involved with. When we start out, we didn't have the technologies. We had the goal. We started the building is not clearly beginning how you get to the end point. It takes a tremendous number of really talented people to pull it off. I think back to just the bit selection process, the basic missions need. This is kind of computer we are building. This is the kinds of using need. Vendor from across the U.S. come into and said, well, we could build a type of computer. Then have to evaluate all this highly technology, highly complex bit. We're just meeting along. We brought in about 150 subject materials expert from across the Department of Energy's complex from the 6 other DOE laboratories to help us evaluate different parts of system, make recommendations on the best path. You just don't have the capabilities to do in many other places in the world. Then from there, each of vendor has armies engineering working on different pieces system. You have like over 100 people in the Oak Ridge National Laboratory. They are working on the system. It takes tremendous amount of efforts and a tremendous number of diverse talent people to pull these things. When you sit back and think about this, start to count all the people that have been a part of this system. It's really breathtaking experience. So we say we use a lot of pretty standard system engineering and the project management result. We use the earn the value of management to track the progress of the projects. This really come down to the manager's complexity. There are a lot of different things to do the manager's complexity, making those investment, material technologies, evaluating along the way. So that's the way buying